We're told that a half-wave diode rectifier circuit, and I'm going to go through this and look at the individual important parts at the same time. So the first important part is that we have a half-wave diode rectifier circuit. So we can go in the notes linked below the like button on page 67 and look up ripple voltage half wave, and we're going to find these notes here. If we wanted a full wave, it's just a little bit lower, but we're dealing with a half wave for this problem. Full wave steps would be very similar to this, so if you have a question like that, it's basically going to be the same steps, just with a different, slightly modified equation. Next thing that we're given is it's driven by a 60 hertz sine wave. So we can see we have a sine wave here, and our frequency is going to be at 60 hertz. Now the peak, it has a peak value of 17 volts. So our VP is equal to 17 volts. If the load resistance of the circuit is driven by 6.4 kilo ohms, so we have 6.4 here, and this is for our load resistance, our R is going to be equal to 6.4 kilo ohms, and we can just write this as 10 cubed, and this is in ohms. We have a maximum ripple voltage, and this is allowed at the output to be 0.4 volts peak to peak. So our VR is going to be 0.4 volts. Now we're asked, what must the minimum value be for the filter capacitor in microfarads? So our units here for microfarads is just going to be like this, where this U is 10 to the negative 6. So now let's go about solving our problem. All we're doing is plugging in these values. So we're going to rewrite this equation here. Because we want to find C, by the way, and we're not given a T, we're given an F. Keep in mind though that T, the period, is just equal to 1 over the frequency. So rewriting this, we are going to have our C on this side equal to a VP over VR. Then we're going to multiply this by 1 over our R times the frequency. And that's just the rewritten version of our equation. So now we just need to plug in our values. We know that our VP is going to be in blue. We know our VR is this green right here. So this is going to go in here. And we know our VF, our RF, the R is actually incorrect. The R is going to go right here. And the VR is going to go where I said the R was going to go, right there. And then our frequency, the 60 hertz, is just going to go right here. So we're just plugging everything in, and then we can put this into a calculator. Notice how I have this 10 to the 6 here as well. And the 10 to the 6 is because we want our value in microfarads. Once we solve this, we're going to get some number, and it's going to be in farads for capacitance. So we multiply this by 1 micro, and this is over 10 to the negative 6. Well, if we want this to be up top, we just flip the units. So instead of being, or I'm sorry, not the units, but the sign out front. So instead of it being a negative 6, it's going to be a positive 6, hence why it's a positive 6 here. And we're going to give us a value of approximately 110.7. So the answer for this problem is going to be 110.7, and this is in microfarads. So that's how we would go about solving this problem. I do not know why it is not writing correctly, but that should be 110.7, and again, it's in microfarads. If you have full wave, again, notes is just a little bit lower, and we have equations right here for the full wave. And if we had different values, we would just substitute them in and solve for it in a calculator.